Hey guys, welcome back to Michelle's STEM Journey. I'm Michelle and I'm here today with another AMC Problem of the Week video. This week's video comes from the year 2021 spring, 10B Problem 16, and it deals with algebra. I hope you guys enjoyed this video and let's get started. The problem states, call a positive integer an uphill integer if every digit is strictly greater than the previous digit. For example, 1,357, 89, and 5 are all uphill integers, but 32, 1,240, and 466 are not. How many uphill integers are divisible by 15? Okay, so the divisibility rule for 15 is that it must be divisible by 3 and 5. Well, in order for a number to be divisible by 5, then it has to end in either 5 or 0. However, in this case, the number cannot end in 0 because there's no number that is greater than 0 that's positive. So that means that our number must end in 5. And then looking at the answer choices, we see that the possible choices are relatively small. So we can just do casework to count the number of digits or the number of integers that satisfy the requirement. So for case 1, let's just have one digit. Well, we already said that it must end in 5, so that means that if it's just one digit, then the only possible number is 5. However, that would not work because 5 is not divisible by 15. And now let's move on to two digits. And because it has to end in 5 and then the digit before 5 must be less than 5, then there are not that many choices. So we'll just start with all of the numbers: 15, 25, 35, 45. Okay, so these are just all the numbers. Well, obviously we see that all these numbers greater than 55 would not work because those are not uphill integers. But then looking at 15, 25, 35, and 45, only 15 and 45 work because 25 and 35 is not divisible by 15. And a way to check that is, yes, 25 and 35 are divisible by 5, but they also must be divisible by 3. Now, a quick way to check if it's divisible by 3 or not is you add up the digits of that number, and if that is divisible by 3, then it is divisible by 3. So, for example, 2 plus 5, that gives us 7. 7 is not divisible by 3. And same goes with 35. So for case 2, we only have two digits, 15 and 45. Okay, so it'll get increasingly harder when the number of digits go up, but we should just select digits from the set 1, 2, 3, 4. And that is because any number that you choose greater than that would be greater than 5. Because remember, it cannot be equal to 5 either because it's just strictly greater. So now we have 3 digits. We know that ends in 5. So we have 125, 135, 145, and then 155 would not work. And then we can increase it to 35 to 45. And then starting in 3, it must just be 345. And then we cannot begin in 4 because it'll give us, for example, 445, which would not work because 4 and 4 are equal to each other, and then 455 wouldn't work either because 5 and 5 would be equal to each other. So in this case, we only have these many numbers, and then we can check the divisibility rule for 3 by adding the digits of each, and we will figure out that only 135 and 345 work because 1 plus 3 plus 5 is 9, and then 3 plus 4 plus 5 is 12, and these are divisible by 3. So for case 3, we have two digits that work, or two numbers that work. And then we have case 4, in which we have 4 digits. And again, only selecting from this set, we have 1, 2, 3, 5, 1, 2, 4, 5, 1, 3, 4, 5, and 2, 3, 4, 5. And then again, check the sums of this. 1 plus 2 plus 3 plus 5 is 11. This is 12. This is 13. And this is 14. So only one that would work is 1,245. So we'll have one integer that works for case 4. And then the last case is case 5, in which we have 5 digits. And the only possible choice would be 1, 2, 3, 4, 5. And then adding up the digits, we get 15, so that is divisible by 15. So now we can just add them up. So we have 2 integers from case 2, 2 integers from case 3, 1 integer from case 4, and then 1 integer from case 5. So that's 2 plus 2 plus 1 plus 1 to give us 6. So the answer is C, 6.